Farah with Accutech. How are you?
I'm good.
Welcome to IMTS Chicago. This is our Diebold shrink fit machine. What you see in front of us here is the Diebold US1100VTP. That is Victor Tom Paul. It stands for vertical, TubeChiller, and it has the pyrometer sensor in here, which is very important for the shrink fit process. When you have shrink fit holders, there are three critical things that need to be maintained on a regular basis. The first thing is you don't want to overheat a holder. By overheating a holder, the ID becomes warped and I can't get a tool in or out. This tool has been scrapped because of that. So you spend $300 for a tool, you don't program it correctly, you've wasted $300. The other problem you have with the shrink fit system is if the coil is not properly placed in the zone for shrinking, it's too high or too low, your bore is going to open up in an opposite direction. In this particular case, this customer had the coil too high in the brand of shrink fit machine he had, and he could not get the shank to go all the way down into the holder, and I explained to him what the issue was. The proper heating cycle should put the coil in the direct area where it's supposed to be, so that my heat zone starts in the middle and then propagates top to bottom. And the Diebold machine makes sure that that happens. Here is how. We have the vertical situation. I can change out from one shank to another shank by simply changing the mounting. I determine what the diameter of my tool is. I have to properly select which one of the ferrite discs, pole disc plates have to go in there. What's very important about this is we talked about the positioning of the coil. So these are made automatically. You can see the difference in the height here, so that my coil properly positions itself where the heat zone is going to be. And I'll demonstrate that shortly. Because it's made out of a ferrite material, I can set it directly on top of the tool. Therefore, all of my heat that's generated goes into my tool, making it a very economical heat source, a 3 to 5 second shrink time versus a 7 to 9 second shrink time. Okay, so this simply drops in and locks into place. We're all set to go there. Now, I have a 1/2 inch tool here in a standard holder. There are 4 different ways that I can shrink this in. The first way with our new Smart Touch control is I can come in and I can do it manually. I can look in my manual and I can see what power they want me to set it at and what time they want me to set it at for the size of that tool. Okay. The benefit of this is if I have a brand that doesn't shrink in that normal 3 to 5 seconds, I can actually come in here and I can adjust my shrink time and I can adjust my power time to save that information. I can then back out, come in here into parameters, and now I can touch user, and I can now load that tool holder part number in there, saving those settings so I don't have to remember what the settings are. All I have to do is know the name of the tool, touch it, and it will automatically shrink it in. Going back to the settings, if we look at the parameter settings, this allows me to automatically set the machine in a manual mode for slim styles. So if I'm using holders such as this that have the 3-degree angle and a thinner wall, I need to use less power and less heat. Okay, so it allows you to do that. It also allows me to use what's called pork wart, which really stands for heavy duty, where I have the thicker wall and therefore I need a little bit more heat and a little bit more power, and then use that as well. But we also have the capabilities of being able to use the TER collet system, which is the thermal grip ER. It's an ER collet that I shrink the holders into, and you can see we have TER 11, 16, 20, 25, 32, and those are the settings that are already predetermined in there. So I'm going to go back to standard, not that it's going to matter at this point. Go back to the Smart Touch main screen, and now I'm going to show you how the Smart Touch works. In the Smart Touch, it is a one-touch system. The reason it's a one-touch system is all I have to do is bring my coil down into position, make sure that it's in place by touching the top of the holder. Okay, it is now going to recognize what size holder and what type of holder I have, and then I simply go in and I hit the start button, And if you'll know that the temperature never exceeds 350 degrees. It allows me to take out the tool. It gives me time to put in the replacement tool. I can stop the heat cycle if I want, or I can go further. If I've already got my tool in and I no longer need the heat there to put it in position, I can skip that cycle. I cannot get to a hot tool. Now my chiller comes up, and what's important about this chiller is it's totally encapsulated, so I have no water splashing around here. I don't lose any liquid. My water comes up, it's agitated with air, and the reason for the agitation for the air is that the coolant has the same temperature all the way around, so I don't have hot and cold spots in my coolant cooling down the tool. Number two is that by agitating the coolant, the heat goes in the air bubbles and dissipates out, allowing my coolant to drop down pretty much at the same temperature it was in the tank, so I don't have a variability in temperature as the day goes on. The last thing about the air bubbles there is that we do use an additive in here that has a rust preventative in it. It's a grinding solution, and that has good bacteria to make sure that it stays consistent. And by agitating it all the time, you don't let off bad bacteria to come in and make the coolant rancid. Okay. As you can see, the tool is completely cool and to the touch. I can't burn myself, and we're all set to go from there. To take the tool out, as you can see, it's just repeating the same process using the OneTouch. And if you'll notice again, it doesn't go past 360 degrees because it doesn't need to. Take the tool out. I can stop the cycle because I'm not going to put a tool back in there. I don't need any more heat. I don't need to have wait time, so I can skip that. Coolant comes up again, and we're all set. You can see in less than a minute time that we've been talking, my tool has been completely processed. So on average with this machine, as an operator gets good with it, he can probably process anywhere from 20 to 40 tools in a single hour. Wow. Safely, efficiently, in the right direction, without overheating any tools. How many shops that you have, and I don't know if your shop has any of those that have a lot of these black tools that have been overheated, these are scrap, they are useless. So therefore, this machine basically saves you from damaging your tools. So the only way this tool is not going to have a lifetime of use is if I crash the front end or I damage the shank here.
We're actually looking for it, so we're starting that exploration process.
Okay.
Between a vertical, horizontal, we run about 30 machines. We are looking for better consistency. We're doing some defense work. We'd like to be more accurate. Exchange, time of exchange is not as important for us. What are the options? What are the different ways to look at it coming up from the exploration phase for us?
Well, the things that you have to consider is the number of tools that you're going to shrink in a single day, okay? That tells you whether you want to be more manual or you want to be more automated, okay? The amount of time that it takes to shrink the tools in. Are your operators shrinking the tools, or are you doing it in a preset area?
Okay.
Okay, if you're doing it in a preset area, you have a person that's dedicated to shrinking and setting the tools. Okay, so if it's your operators, the longer they're away from the machine, the less time that your spindle's running. So it's very important that they're not spending time here. Well, by spending time here, you don't want them thinking about what settings they have to set it to. You want to come here, put the tool. So with the OneTouch, I simply put the tool in there, it recognizes everything. I shrink out the bad tool, I put the new tool in the same cycle. So essentially within a 2-minute period of time, he can be back headed over to his machine with no downtime. Now, what's the difference between vertical and horizontal? Well, vertical is up and down and horizontal is this way. Kidding. The advantages of the horizontal unit is that I have the same option here, that I just simply slide my coil over into position, having my discs here, okay? And then I can have the pyrometer and the OneTouch system here that does the same thing there. I have to cool the tool, so I have a separate unit over here that looks like basically a closet, and I close the door and it looks similar to that where it agitates the water, so it's separately. It's a modular type. But the advantage of the horizontal is you're doing defense work, aerospace work, you get into some of your long shrinks sometimes. You get into the multiple steps where you're putting an extension inside. Okay, so I am limited to a 500 millimeter length of tool there. So the maximum I can shrink there. With this unit here, I have 500 millimeters here. However, with our universal vise, if I need to shrink an extension in, I bring this over, I shrink the extension in. If the tip of my cutting tool is way out here, but beyond this reach, all I do is bring my tool back, grab it on the barrel, wherever that may be. My shank can be all the way here, but my shrink unit's right here. I bring it in, shrink it in, and now I can do all of my step tools that way. So that's the benefit of the horizontal machine. Cost-wise, the horizontal machine and the tabletop vertical are basically the same. As you can see, there are 4 screws back here. If I want to do length adjustment presetting, all I do is mount that attachment here. It has a dial indicator in. I bring in my coil. I flip the dial indicator over. When I insert my tool, I pull it out to match the dial indicator that I want size. Then when it's securely held in there, I bring the dial back, slide my coil off, and I'm all set to go. The same thing with the vertical model. I do it in bringing it down after the coil comes down. So that would be the difference between the horizontal and vertical, depending on what your application is.
Okay.
Okay?
Gotcha.